Welcome again. In this lecture, we will solve few more questions related to the partial differential equation with constant coefficient, and then we will move towards the non-homogeneous partial differential equation. So let us start with some questions. So solve del to z upon del x2 minus 4 del to z upon del x del y plus 3 del to z upon del y2 equal to the square root of x plus 3y. Solution. As we know that del 2 upon del x2 is d square, so we can also write it as d square. Here del 2 upon del x del y is d into d dash, and this one is d dash square, and z is outside, and this term can be written as x plus 3y power half. So therefore our auxiliary equation will be, for auxiliary equation we replace our d by m and d dash by 1. Now as we are computing the complementary function, so our right hand side will be 0. Now from here our roots are m minus 1 into m minus 3. So we can say that our m is 1 and 3. Therefore CF equal to C1 e power, as we have distinct roots, so therefore our CF will be f1 y plus x plus f2 y plus 3x. This is our complementary function. Now the PI will be particular integration is equal to 1 upon, now we have these two factors, one is d minus d dash and other is d minus 3d dash. So in the bracket we have x plus 3y power half. Okay. Now this is of the type ax plus by. So we will replace our d by a and d dash by b. So let us replace our d by a is 1 and d dash by b is 3. Here our a is 1, so this will be 1, and d dash is b, which is your 3, so this will be your 9. Now as the degree of this denominator is 2, so we will integrate this term 2 times, taking this one as a single variable. So this will be your, say this is your u, power half du, where our u will be x plus 3y. As this one has degree 2 and the bracket is of the type f of ax plus by, so we will replace our d by a, d dash by b, and we will do the integration up to the order of this function. So now the integration of u to power half will be, now this is your minus 8 into minus 2, that means this will be your 16. Now here the integration of u to power half will be, one time integration will be u to power 3 by 2 upon 3 by 2, and then second time this will be your u to power 5 upon 2 upon 3 by 2 into 5 by 2. So this will be your 4, that means this is your 4 is your 12, and this will be your 60. U to power 5 by 2 and u over this one, or 5 by 2. So our complete answer is CF plus PI, which is equal to f1y plus x plus f2y plus 3x plus this complementary function, this particular integral, x plus 3y power 5 by 2. So this is your answer. Let us solve another question, and this is your solve d square minus 5dt dash plus 6d dash square equal to y cos x, or we can also have sin x. So this is our question. Solution. Our auxiliary equation will be, we can replace our d by m and d dash by 1. So this will be your auxiliary equation. which has two roots. One is -2 and second is 1 is 2 and second is 3. So we will have these two factors. So our m is 2 and 3. So the complementary function will be f1 y plus 2x plus f2 y plus 3x. Now our pi will be d square minus 5dd dash plus 6d dash square, and in the bracket we will have y sin x. Now here we can see that this term has two factors. One was your d minus 2d dash and the second one is d minus 3d dash. So here we will have d minus dd dash and d minus 3d dash. These are two factors, and in the bracket I think there is something wrong. Our auxiliary equation was 5 square minus 5m plus 6. Okay, this was equal to 0. So our factor was d minus 2d dash. Here we will have 2d dash. Okay, in the bracket we have y sin x. So we have two factors. One is d minus 2d dash and another one is d minus 3d dash, and their product will be this one. Now we cannot use some function of ax plus by formula, because for that this has to be in the form of ax plus by. We cannot also use x into y formula, because it is sin x is not in the algebraic form. So let us apply the general rule, and the general rule was and this can be written as 1 upon d minus 3d dash of y sin x, and let us apply this formula as 1 upon d minus md dash of function of xy is equal to integration of x, then y was c minus mx dx, where our c was y plus mx. Now let us apply this formula. So if we apply this formula, then this will be equal to, and this will be equal to f. That means this will be your integration of sin x, and we will replace our y by c minus mx. So this will be your c minus mx into sin x. The formula says that our y will be replaced by c minus mx, where c will be y plus mx. Our y is equal to c minus mx. So if we integrate this one, we will get, again use the Bernoulli rule of integration. So this will be our c minus mx. Integration of sin will be minus cos. Then we will have minus sin, and then the differentiation of c minus mx will be minus m. So this will be plus m, and integration of cos will be minus sin x. Integration of cos x is sin x, and we have already a minus sign. So here you can see that in place of m we have 3. So this will be your 3x. Now again c minus 3x was, now c minus 3x was y, so we can also write it as y minus y cos x minus 3 sin x. So after one time application of this formula, we have this result. Now again apply this formula for this product, for this factor. So this will be equal to integration, let us replace our y by c minus mx. Here we can see that our m is 2. So let us replace our y by c minus m. M is 2. So this will be c minus 2x cos x minus 3x sin x dx. Using this formula, we have to replace our y by c minus mx, where m is the coefficient of d dash. Here you can see that coefficient of d dash is 2. So we have replaced our y by c minus 2x. Now let us integrate this one. The integration of this one will be integration of cos x, which is your sin x. Then we will have minus sin, and the differentiation of c minus 2x will be minus 2, so this will be a plus 2, and integration of sin x will be minus cos x. Then here integration of sin x is minus cos x, so this will be a plus 3 cos x. And c minus 2x what? Where y is equal to c minus 2x. So c minus 2x is y, so this will be y sin x minus 2 cos x plus 3 cos x. So our pi will be, so therefore our pi is equal to y sin x plus cos x. So therefore our answer will be z equal to CF plus pi, and CF was I think f1y plus 2x, f2y plus 3x, and pi is y sin x plus cos x. So this is your solution of the problem. Now next question. So this is your solution. Then we have the question again using the general rule. We can solve this question. D square plus 2d dash plus d dash square into z equal to 2 cos y minus x sin y. Using the same technique we can also solve this question. Let us solve it. Solution. Auxiliary equation will be, let us replace our d by m, d dash by 1. So this will be equal to 0. So we have m plus 1 whole square equal to 0. So our roots are minus 1 comma minus 1. So the complementary function is equal to f1 y minus x. As you can see that these roots are equal to each other, so we will have f1 y minus x plus f2 y minus x, x times f2 y minus x, because we have repeated root. Now pi will be, this will be your d plus d dash whole square, and in the bracket we will have 2 cos y. We can break it into part. For the second part we will have x sin y. Now this y can be written as, the first term can be written as cos 0x plus 1y, and for the second term we will use the general rule of integration. So now as our a is 0, b is 1, so let us replace our d by a, that is 0, and d dash by 1. So this will be 1, and as the degree of this term is 2, so we will integrate this cos y 2 times. Therefore, now let us replace our d by a, that is 0, and d dash by b, that is 1. So this will be 1, and as the degree of this term is 2, so we will integrate this term 2 times. So the integration of cos y will be, let us integrate this one 2 times. Here we have only one variable, so we are integrating with respect to y. If suppose that here we can, if we have x plus y, then we will assume x plus y as a u to take it as a single variable. But as we have only y, so we are integrating with respect to y. Now here we will use the general rule of integration. For that, this bracket can be written as d minus minus 1 d dash of x cos x sin y. Now in one time integration of cos y will be sin y, then we will have minus cos y. So this is your minus cos y, and here we will have, here we can see that this is equal to integration x. Now we will have to replace our sin, our y by, we will have to replace our y by c minus mx. So this will be a c minus, we will have to replace our y by c minus mx, m is minus 1, so this will be a c plus x dx, where y equal to c minus mx, and m is minus 1, so this will be a c plus x. And this is equal to minus cos y 1 upon d plus d dash, and then integration of this will be x, integration of sin will be minus cos, then we will have minus sign, differentiation of x will be 1, and then the integration of this bracket will be minus sign c plus x. So let us replace our c plus x by y. So this will be minus x cos y, and here we will have minus minus plus, and this is your y. So we will get sin y. Now again using the same formula, we get, and this is equal to minus cos y minus, and here we will have integration, and then in the bracket we will replace our cos y by c minus mx. So this will be c plus x, and again here we will replace our y by c plus x, and then integration with respect to x. You can see that here we have replaced our y by c minus mx as m is minus 1, so this will be c plus x. So this is equal to minus cos y, and then here we can use the Leibniz rule, or we can use the Bernoulli rule of integration. So this is your x, integration of cos will be your sin x plus c plus x, then we will have minus sign, differentiation of x will be 1, so this is 1, and the integration of sin will be minus cos. So this is the first term, and then integration of sin is minus cos. So this is equal to minus cos y, and here you can say that this is your x into sin y, then here we will have minus minus plus, and here is the minus sign, so this will be your minus cos y, and again here we have minus cos y. So our answer will be, now you can say that here x sin y is the first term, then we will have this is equal to minus 2 cos y, so this will be plus 2 cos y, so we have plus cos y. Therefore our answer is complementary function plus particular integral. So this is a complete solution of the partial differential equation. Then the last question related to this homogeneous partial differential equation is to solve this differential equation, this partial differential equation, e to the minus xy sin. We will solve one more question of the algebraic form. Now let us solve this question. So auxiliary equation will be if we replace our d by m and d dash by 1, we will have the roots as m minus 1, m plus 1 equal to 0. So you can see that m is 1 and minus 1. So our CF will be f1 y plus x plus f2 y minus x, and pi will be d square minus d dash square of the bracket, this one. Now here we can take this e to the power ax plus by common, we can take this ax plus by common, and then our d will be replaced by d plus a is 1. So our d will be replaced by d plus a, and d dash will be replaced by d dash plus b, and d is minus 1. So this will be d plus 1 whole square minus d dash minus 1 whole square, and in the bracket we will have sin 2x plus 3y. So this is equal to e to the power x minus y. Then here you can see that the first term is d square, then we have plus 1, and here we will get minus 1, so that will be cancelled. From here we will have d dash square, so this will be minus d dash square. Then we will have 2d, and from here we will have minus a square plus b square plus 2ab, and then here we will get a square plus b square minus 2ab, so this will be plus 2d dash, and then in the bracket we have sin 2x plus 3y. So this is the factorization of this one, and we can also use it as a square minus b square. I think that will be better. Then this will be your a plus b, a minus b. So now use our formula. So our d square will be replaced by, please note down that here this factor is not homogeneous. So we cannot use the formula of the type ax plus by. We can only use the formula when this denominator term is homogeneous. Here you can see that this is not homogeneous. If you wish to use that formula, then we will have to factorize it in two parts, and then for the homogeneous part we will use the formula for f of ax plus by. We can also use that formula, or you can directly replace our d square by minus a square. So minus a square will be minus 4, and d dash square by minus b square. So this will be your minus minus plus 9, then 2d plus 2d dash, and in the bracket we have sin 2x plus 3y. Here we have replaced our d square by minus a square, so this is your minus 4, and d dash square by minus b square, so this is your minus 9. So the first term is minus 4 and the second term is plus 9. So this is equal to e to power x minus y. Then we will have 2d plus 2d dash, and this will be plus 5. Then in the bracket we have sin 2x plus 3y. Okay. Now we have two choices. Either rationalize this term by taking its conjugate in the numerator or in the denominator, or replace. We can also write this sin theta, because we know that cos theta equal to, we know that e to power I theta equal to cos theta plus I sin theta. So we can say that sin theta is the imaginary part of e to power I theta. So let us replace this sin theta by e to power I theta, and finally we will take the imaginary part. So the imaginary part of this term, 2d plus 2d dash plus 5, and then in the bracket we will have 2 e to power I theta, that means I2x plus 3y. Now let us replace our d by a is 2i, so this will be your 2, and for d we have 2i, so this will be your 2i. Again we will replace our d dash by b, and for b we have 3i, so this will be 3i plus 5, and in the bracket we have e to power I 2x plus 3y. So this is equal to e to power x minus y, then in the bracket we have the imaginary part of, now this is your 4i plus this is your 6i, that means 10i plus 5. Then we can write e to power I theta as cos theta plus I times sin theta. Now this is equal to imaginary part. Let us take conjugate of this one, which is your 10i minus 5, and then we will have, here in the denominator we will have 10i plus 5 into 10i minus 5. So this will be your 100i square minus 25, because we will have 10i plus 5 into 10i minus 5. So this will be equal to 100 a plus b minus b, that means a square minus b square. And in the bracket we have cos 2x plus 3y plus I sin 2x plus 3y. And this is equal to e to power x minus y, imaginary part of, now this will be your minus 125. Then in the bracket we have cos 2x plus 3y plus I sin 2x plus 3y. Now let us take the imaginary part of the bracket. So if you multiply this I by this term, then we will get the imaginary part. So we will get minus 10 upon 125 into cos 2x plus 3y. This is your first term. And then if you multiply minus 5 into this term, then again we will get the imaginary part, and this will be your sine 2x plus 3y, and rest are the real parts. So our answer is e to the power x minus y. If you want to take this minus sign common, then we will have, now here we will have 5 to the 10, and here we can have 25 cos 2x plus 3y, and here we will get minus 1.25 sin 2x plus 3y. Therefore our complete answer is z equal to Ca plus Pi. So this is all about this question. We can also take this 25 common. So in the bracket we have this answer and it is correct. So this is the solution of this question. Now our final question is, let us solve d square minus 2d ds of z equal to e to the power 2x plus x cube into y. And this will be our last question. So auxiliary equation is m square minus 2m equal to 0. So we will have m equal to 2 and 0. So our complementary function will be, therefore complementary function will be f1 y plus mx, m is 0, plus f2 y plus mx, m is 2. So this is our complementary function. Then for the pi, let us break this in two parts. Our pi will be equal to d square minus 2d d dash. Then in the bracket we will have e to the power 2x plus x cube into y. So let us break it in two parts. D square minus 2d d dash. Then e to the power 2x. E to the power 2x can also be written as 2x plus 0y. Then d square minus 2d d dash. Then in the bracket we will have x cube y. As you can see that here the power of x is greater than the power of y. So we will take d square common. And here we will replace our d by a and d dash by b. So if we replace our d by a, so this will be a 4. And again, here we will replace our d by a, then this will be a 4. So that means 4 minus 4 is, we will replace our d by a, so this is your 4, and d dash by b, and here you can see that our d dash is 0, so this term will be 0. So we will get just 1 by 4, then in the bracket e to the power 2x plus 0y, which is your e to the power 2x. Then here let us take 1 upon d square common. So if we take 1 upon d square common, then in the bracket we will get minus 2 d dash upon d, and after taking it in the numerator we will have minus n, then in the bracket we will get x cube y. So this is equal to 1 upon 4 e to the power 2x. Now use the binomial expansion. So this will be your d 1 minus x plus x square and so on. So you can see that this is equal to 1 by 4 e to the power 2x 1 upon d square. Now as we multiply this term with 1, we will get x cube y. Now the differentiation, d dash stands for the partial differentiation with respect to y. Now the partial differentiation of this bracket with respect to y will be x cube. So we will get 2 upon d of x cube. Then here we will get the d dash square. Now d dash square of this bracket will be 0. That means the double differentiation, the double differentiation of this bracket with respect to y will be 0. So after this term, all the term will be 0. So this is our pi. Now 1 upon d square stands for the double integration. Now the one time, let us simplify it, x cube y. Now the integration of this x cube will be x power 4 upon 4. So we will get x power 4 upon 4, and that means this is your 2. Now let us integrate 2 times. Now the 2 time integration of x cube, after 1 time integration we will get x power 4 upon 4. Then after second time integration we will get x power 5 upon 20 y. Then here after 2 time integration we will get x power 5 upon 10. Then for the next time we will get x power 6 upon 60. Therefore our complete answer is Ca plus Pi. this is all about this lecture. Now in the next lecture I will discuss about the non-homogeneous partial differential equation. Thank you.